Aloha and good morning. We're going to be working on project 1.2, the Blink project here. So if you look at the screen that we have, shows the parts that we need here. We've got our Pico W, which is over here on the right. We've got our USB cable. We've got our breadboard. We have the LED light. We have a 220 ohm resistor. We're just going to use one of those. And if you're having trouble finding those, you should look in the pack that has all the resistors together. And we're going to need one jumper, and it can be any color. And I don't think they actually have the green that they show here in our packs. Just grab any color jumper, it should be fine. Here we have a little bit of background information on LEDs, talking about how there are diodes. The information that we really want to look at is down here. And we're going to be using a red LED. And the red LED, you'll notice that it can accept voltage between 1.9 and 2.2 volts, or the maximum current it's going to accept is 20 milliamps, and recommended current is 10 milliamps. So it can accept anywhere between 10 and 20. And we're going to use the 220 ohm to put this to about 15 milliamps. And I will bring up my handy dandy calculator to show you how we're going to be doing that math. So if you remember Ohm's law down here, you've got Ohm's law, and Ohm's law allows you to calculate your the current. Let me pull it up here. So you can see that your current, voltage, and resistance are all related in the formula where I equals V divided by R, where I is your current, V is the voltage, and R is the resistance. So in this equation, we know that we have 3.3 volts being supplied by the Pico, and we know that the resistance is going to be 220 ohms. So we can plug that into the equation simply by saying 3.3 divided by 220, and that's going to give us the 0.015 or 15 milliamps. So this is milli. So if you move it over, that's going to be 15 milliamps. So if we look over here, we can see that 15 milliamps is dead smack in the middle between the recommended and the maximum. So that's how we figure out if we're going to be safe using this LED. So we go down here, and it shows us a little bit about our breadboards. And the videos that I had you watch earlier should give you a lot of background on that. But this is what your breadboard looks like. You've got your power rails going the length here. So if you plug in here, it goes all the way down. Use the blue for your ground, the red for your power. And then your Pico is going to be going dead smack, right here in the center. And you're going to be able to use these pins over here. Note that these pins all here that are green lines, that's considered one connected circuit. If you look at the bottom here, this is what, when you strip off the bottom of your breadboard, which I do not suggest you do, it looks like this. So you've got connectivity going all the way up and down there, and parallel for the power rails. So anyway, it says here, connect the Pico to USB power. I don't suggest that. We're not going to do that just yet. We're going to be building this circuit right here. If you don't understand what this looks like, don't worry. Note that this is the LED symbol, and it showed that up above. So you have it right here. That's over here. And the resistor is this right here. Now you can think of that as, it's making it go left and right, like switchbacks to, to slow it down, which is exactly what it's doing. So we're going to build this right here. And we're going to put, first of all, we're going to put our Pico onto the board in the center. I've already done that, so I won't actually be doing that. Then we're going to take the resistor, and we're going to put the resistor on pin 15, and we're going to run it to the long pin, which is the positive side of the LED. And then we're going to take the negative side, and we're going to run it with a jumper all the way back to ground. So we're going to take, again, we're going to have pin 15. It's going to connect with a resistor to the positive pole of the LED, and then the negative will go with this jumper back to ground. So what we're doing here is remember, anything on the that's perpendicular here, any one of these holes is connected to the next. So the ground here on our Pico is connected here with the lines. So if we plug in here, it's the same as plugging into our ground. So then the wire connects it to the negative side of the LED. And then it goes through here and it connects. And then from here, we're going backwards, but you get the idea. From here, the long pin, we go the resistor, and it goes back to power. So that's how everything is connected here. So because we've plugged in here, you know, all these are on the same one, so it connects to the negative pin. And then, you know, it goes through here, the positive pin comes out, and everything here is connected. So it hits the resistor, and it connects over to here, where it goes again to the pin 15. So we're going to set that up now. So I'm going to switch my view. I'm going to stop sharing, and I'm going to switch my view to a Pico that I've set up here. And you'll notice that we have here the stickers. Those I kind of followed what they had in our PDF file, but not exactly. So we're gonna go ahead and recreate the image that they had for us. So what we're gonna do, I've got, first of all, our LED. I've got our 220 ohm resistor, and I have right here just a jumper pin. So we're gonna set this up as they mentioned. So we're gonna take the LED, and it's kind of hard for me to do this right now with right here, but what we're gonna do is we'll take the positive and we'll put it in one channel, and then we've got, let me move that to the side so you can see it a little bit better. So we've got the positive is on top here, and we're gonna plug it in like that. So now we have, well, let's bring it down a little bit more because we want to give ourselves a little bit of space here. So the longer one is on top. Then I'm going to take our resistor here, and our resistor is going to connect pin 15 to our positive terminal here. So I'm going to put one end right here on 15. So I've got one end on 15. Then I've got the other end, which is going to go to the positive side here. So hoping you can see that. So I've got one on pin 15, and then I've got one down here on the positive end. Just to make sure that we're doing this right, we pull it up. Yes, that's the positive end. So we go to put that back in. And now we have to set up the negative end. So the negative end, we're going to actually set up using our two ends of our wire. So I'm going to go over and I'm going to go to the ground for this. So if you watch, we're going to go, and again, I apologize because I'm looking at the screen and trying to work with this, so it makes it easier for you to see. So I plug into ground right here, and then I take the other end and I go out to the negative end of our LED. So notice that we have ground going down to here to the, let me pull that, to the short end of the LED. And then I've got the long end going over here to the resistor, and that goes over here to pin 15. So in theory, if I hook this up, if I plug this in right now, and I'll do that, you can't see me do this, but I'm plugging it into power right now, and hopefully I don't blow anything up, ha ha ha. So I'm gonna plug this in, and hold on just a second. I'm having trouble plugging in the USB power. There we go. Nothing is exploding. So far, so good. So what I'm going to do now is I'm going to share the screen for the code again. And this is going to be, let's see. All right, so let me close out this screen right here and the calculator as well. So here's the code that we've got for this. And the code is essentially saying here, we're going to import pin from machine. We're going to import time so we can do time calculations here. We're saying LED, we're going to use pin 15 out. So we're going to be sending out to pin 15. So we're going to do a loop, and that loop is basically setting up LED.value1, which is going to it's going to send power to it. It's going to draw it high. So you're going to have your LED turning on. Then we're going to sleep it for 5 seconds. Then we're going to draw it low. The power is going to go to low, so it's going to turn it off. And then we're going to sleep another 0.5 seconds. Then we're going to go back and we're going to just loop. And this except here that says pass, all that's doing is it's saying that if we have trouble with our output there, we're just going to go ahead and ignore that. We're just going to go ahead and pass. So if you look down here at the bottom of the screen, Pico connected. So I'm just going to go ahead and click on the run button here. When I click on run, you'll notice that our LED, well, let me, I think that's showing in the top of the screen. Our LED is now blinking. So I'm going to switch back. I'm going to stop the share and just show the LED blink there. And it works. So that's really nice. So what I want to do now is play around. And I showed some people this idea earlier, but just to kind of play around with the idea, it'd be nice if we, blinking on and off, that's fun. We can go back into our code, and I'll just do this right now. I'll set it to 0.1 and 0.1, and then I will stop it. So when I stop it, it stops while it's red and lit up. I'm going to hit run, and you see by changing our that sleep value to 0.1, it does that. If you want to make it look freaky, we can do something a little bit different. We can come in here and let's see, I'll share my screen again. Let's look at code and let's do something. Shall we do random import? Is it random? Yeah, import random. And let's see. Wait, it's not finding that. Is that not, is it random's not accessed? Not sure if this is going to work, but we will try it anyway. So I'm going to come up with sleep time equals random dot rand int, and we give it a number between 0 and 1. And we will go ahead and instead of doing a sleep here for 0.01, we'll do sleep time and sleep time. Let's just go ahead and see if that, nope, that is giving us a, all right, so it's not exactly what I wanted. So I'm going to go ahead over here and I'm going to do a print screen of sleep time. I actually know what it is. It's 0. What's happening right now is it's getting either 0 or 1. So we're going to say the random, it's going to be that divided by, let's say 25, just to make it exciting. So if I hit stop and then run, we're going to see it doing a lot of, yeah, that's a little bit too fast there. So if we change that to 10, how does that look? Oops, I'm not getting what I expected. So I'm going to stop here real quick. I'm going to do a print of sleep time. Oops, if I can do a print of sleep time, just to see what my values are here. And I'm getting 0.1 as the amount of time that's going through there. But the problem is, of course, that I have put this outside of my loop. So if we move this down into our loop, and remember that it does matter indentation. So now when I put that inside the loop and I rerun it, we're going to see that it's doing a nice, 0.0 or 0.1. But now let's give it a little bit more excitement here. Or actually, hold on. Instead of giving it a number between 0 and 1, let's give it a number between 0 and 50. And just let it run with that. So you're going to see that we get random blinks here. So the number that's generated for the sleep time is going to be different. So it's going to randomly blink here. So I just kind of like playing around with it and mixing it up a little bit. So this is our project, but just made a little bit more interesting. So feel free to play around with stuff like this and go wild, because LEDs can be a lot of fun to play around with. And that's what we're doing here. Yeah. So go crazy with it. So anyway, this has been the 1.2 LED blink. Hopefully this has been helpful to some of the people that have been having trouble here. And yeah, so I've gone ahead and made quite the camera rig here to be able to show these projects. So I'm going to try to illustrate some of the projects like this going forward. So anyway, this is my video homework. Hope you've enjoyed it, and I will see you later.